Continuing to use the substitution method, in this problem we're given that x plus 4y equals 9 and that x equals 3y minus 5. Based on the fact that x is the same thing as 3y minus 5, which we see here in the second statement, I'm going to change the first equation accordingly, changing x into 3y minus 5. So the first equation will be rewritten as 3y minus 5 plus 4y equals 9. Now we can start using the rules of solving equations that we've used throughout the year. If I cover up the minus 5 part momentarily, you can see what I have is 3y plus 4y. 3y plus 4y simplifies to make 7y. So now I have 7y minus 5 equals 9. As we've done throughout the year, we strongly desire to move constants, or lonesome numbers, to the right side of the equal sign. As you can see, 9 is already there, but 5 isn't. So I'm now going to take the time to move 5 over to the other side. As you can see, 5 has a subtraction sign in front of it, so in order to do that, I'm going to need to add 5 to both sides. When I add 5 to both sides, the result is 7y equals 14. Now what's left is a simple multiplication equation, which I can solve by dividing. I need to divide each side by 7. And when I divide across by 7, I get y equals 2, which is half of the solution. Now I want to go back to the top and identify the shortest looking equation. Now in reality, both of these are actually very short equations, so it really comes down to personal preference. But I want to pick the second one, x equals 3y minus 5. We know from what we solved in the first column that y equals 2. So I'm going to take time to change y into 2. So the result is now x equals 3 times 2 minus 5. 3 times 2, of course, simplifies to make 6. So the problem is really asking us to find the result of 6 minus 5. 6 minus 5, of course, equals 1, and that's the value of x. So the solutions here are that x equals 1 and y equals 2, or you could write the ordered pair 1, 2, which would also suffice for a properly written solution.